Hi all. The topic for today's discussion is disk scheduling. Okay, so before learning disk scheduling, we need to know what is the need of disk we are using in a computer, normal laptops, wherever. Okay, so disk main purpose is storage. Okay, so instead of the main memory storage is very less, we are using some additional storage called as hard disk, CD drive, pen drive. Okay, so this all are comes under permanent storage devices. Okay, so when we are storing a content, saving the data, so all contents are stored into this hard disk. Okay, so as secondary storage devices, we can save the contents in CD also. Okay, compact disk. So before scheduling concept, we need to know how the disk is. Okay, so this is the architecture for disk. Okay, so we know the disk is in the form of this circle. Okay, in this manner. So this circle is having a spindle. In this CD is divided into number of tracks as well as sectors. Okay, so this circle is called as track named as T. This track is again divided into small portions. These small portions are known as sectors. So whatever content we are saving in a CD drive, CD compact disk, that each content is stored within this sector. Okay, so this sector is used to save the content. So when consider this disk is having 100 songs. Okay, I need to play immediately 50-second song. Okay, so when I play and selected 50-second song, this with the support of this spindle, this cylinder rotates. Okay, this plater rotates with the support of the cylinder, and immediately this discom, this is called as discom. Okay, this is used to perform read write operation. This discom immediately positioned to a place called as 55th sector. Okay, so because of that, we can able to hear the song whatever we need, which is stored into the CD. It may be 100th file, first file, 70th file, whatever it is. Okay, so this is the mechanism, hardware mechanism followed in the disk drive. Okay, so next is at the time of storing the content. Okay, how this disk scheduling is happens, how the particular contents are stored, or when we are accessing a content, 70th content, 100th content, whatever it is, when we are accessing a content from elsewhere, how this disk is reading a content immediately. Okay, so that is done with the help of disk scheduling. So in this disk scheduling, so it's a problematic based concept. Before learning disk scheduling, you have to know the basic concept of disk scheduling, which means some of the terms used in disk scheduling. So these are the terms used. Okay, seek time. So under seek access time, these are the two things mentioned, two key terms, seek time as well as rotational latency. Okay, so access time means we know how much time it takes to play a particular song is called as access time. Okay, so this access time can be divided into two, seek time as well as rotational latency. So seek time means time taken for a disk to move from the head to desired sector. Okay, as I said earlier, when I started inserted CD drive, immediately I want to play a 55th song. Okay, so as I inserted the CD disc now the sector is in a zeroth position, in a head position. So from the head to it needs to reach the 50th sector. Okay, so how much time it takes to reach from head to 50th sector is called as seek time. Okay, and another one key term used is rotational latency. Okay, so this is additional time waiting for the disk to rotate the desired set to the disk head. So how much time we are waiting to get the data from the particular sector is called as rotational latency, which means a waiting time. Okay, so in this operating system, the main aim of disk scheduling is minimize the seek time. So whenever I played 100 song, 50th or 70th, I need to immediately hear that song, or I immediately watch that particular content of the video. Okay, nobody is ready to wait. Okay, so that's why we need to minimize the seek time. That is the best thing of OS, minimization of seek time in disk scheduling. So another one key term used here is bandwidth. Okay, so the disk bandwidth is total number of bytes transferred divided by the number of time between the first request for service and the completion time of last transfer. So how much byte transferred? If I played one song at that time, to play that full song, how much byte of data transfer? Okay, divided by the amount of time request get started to how much time it takes to complete the data access. Okay, that is called as bandwidth. So at the time of solving the problem, you will calculate the seek time, or how much time it takes to transfer from one position to another, or from head to another sector. So to explain this disk scheduling algorithm, we have set of scheduling algorithms like CPU scheduling. Okay. So the some of the scheduling algorithms are FCFS, SSTF, then scan, CScan, CLOOK. Okay. Totally we are using 5 types of disk scheduling algorithm here to transfer the data and calculate the seek time. Okay, so consider here in this problem, we illustrate scheduling algorithm with the request queue 0 to 199. Okay, so consider the request queue starts from 0 to 199, and the disk arm wants to traverse these are the sectors. So these are the number of sectors, or consider these are the number of songs you want to hear. Okay, but now the song is played in 53rd song, which means the head pointer is at the position of 53rd. I want to traverse this many sectors. Okay, now I am going to apply this 5 kinds of algorithm to calculate the shortest seek time. Okay, to find the shortest seek time. So we'll move to the first problem, FCFS. Okay, so these are the Q given, our head is at the position of 53rd. Okay, so we will solve this. So in the concept itself, it is mentioned that the cylinder tracks are 0 to 199. Okay. So you please draw a line and starts from 0 to 199. So we know that the head is at the position of 53rd. Okay, so you please mark, see here in the ascending order, please mark the numbers in the line from 0 to 199. While considering in ascending order, 14 is the next number after 0, right? So mark here 14. After that, we can consider 37 here, then 65, 67, then 98. After that, 122. Okay, 122, 124. So after that, finally 183. 183, the cylinder starts and ending is 0 to 199. So in between this, our head is now with the position of 53. So the 53 will come here. Okay. 53. So now my head is in the position of here. Okay. So based upon the concept of FCFS, first come, first service, I need to traverse the queue, traverse the disk sector. Okay. So start from 53. What is the first sector I need to traverse? 98. Okay, so immediately move from 53rd to 98. Okay, just draw a line. 53 to 98. Okay, then 98 to 183. Okay, 98 to 183. Then 183 to 37. 93 to 30. Just draw a line from one sector to another sector. Okay, then 37 to 122. 37 to 122. Then 122 to 14. Okay, 122 to 14. Then 14 to 124. Then 124 to 65. Then 65 to 67. Okay, this is the way we have to draw to find the seek time. Okay, so now how will you find the seek time? Okay, the thing you need to calculate is just subtract the difference between one sector to another next sector. Okay, so what is where the head position is initially 53. Okay, so where it is moved, the first request 98. So please calculate 98 minus 53 plus, then which one is the next request? 183. So 183 minus 98. Like this you subtract everything. Okay. So 183 to 98. After that 37. Okay. Then 37. Okay. 37 minus 183. After that, 122 minus 37 plus 14 minus 122 plus 124 minus 14 plus 65 minus 124 plus 67 minus 65. Finally, you add everything. Okay, subtract and add everything. So you will get the answer of 640. Okay, so 640 cylinders moved to transfer from the head position to this. Okay, so 640 cylinders totally. This particular disk arm is moved to search the data, okay, or retrieve the data. Okay, so this is the answer for FCFS. Okay, so I think it's clear. You will draw a line from 0 to 199. It's already mentioned the size of the disk is 0 to 199. So you are mentioning that. So after that, the head starts from 53. This is the queue request. So you are arranging and marking the numbers in ascending order. So after that, it starts from 53 to next disk you are traversing. Okay, no need to worry about any other thing. And finally, you are subtracting the difference. Okay, calculating the difference between one sector to another sector, adding everything. Finally, you are getting out solution. That is the number of cylinders it traversed. Okay. Then next concept. Next is SSTM, shortest seek time first. Okay, so see read the line, shortest seek time, select the request with the minimum seek time from the current position. Okay, so from the head node, in the previous example, the head is at the position of 53. Okay, from that, it will check the number of requests. So based upon the request, it will find the next shortest one. Okay, after that, based upon the shortest distance, it will traverse the remaining sectors. Okay, like this. So this is the example problem given here, SSTF. Same problem I'm considering. This is the queue size. Okay. So we are starting from 53rd position. Okay, starting from 53rd. Okay, so from 53rd to what is our concept? Shortest seek time first. So I'm checking from 53 whether 65 is shortest distance or 37 is shortest distance. Okay, so compared to both distance, 65 is nearer. Okay, so I am starting from 53rd to 65. Okay, next nearest one is 67. So from 67 to we have two options, either 37 or 98. Okay, here also the difference between 65 to 98 and 37, 37 is nearer. So I'm traversing to 37. So again, I'm checking from 37 to either 14 or 98. Okay, 14 is nearer. Like this, I'm traversing to the shortest distance. That's why this is called as shortest seek time first. Okay, starts from the head node and check the left and right request, which one is lesser, shorter. In that track, it is transfer. Okay, for each transaction. Okay, so for each rotation, it is checking the nearest one and then traversing. Finally, you are same thing. You are calculating the difference between this 53 minus 65 plus 65 minus 67, like this it goes on. Okay, and finally you are receiving the answer called as 236 cylinder. Okay, so for the same problem, the first concept is FCFS. There, the disk is traversed for 640 cylinder. Same question, same kind of request. The disk is traversing for only 236 cylinders in the shortest seek time first. Okay, so your operating system will consider only the best algorithm always. Okay, so this is the second concept, SSTS. And the next one is scan. So, okay, like a scan. If we have a document, we are scanning means it will scan the entire content which is present in the document. Okay, same thing. The disk count starts at one end of the disk and move towards the other end, servicing the request until it gets to the other end of the disk. Okay, so this concept applied by the scan algorithm is an application of elevator lift. Lift concept is based upon this scan algorithm. Okay, so same problem given here. These are the queue requests. The head starts from the 53rd position. So what is the definition given? It starts from one end and it scans the till the end whatever the in between requests are available. Okay, so based upon our question, the head starts at where 53rd. Okay, so by default I am starting at 53 and moving to the left side. Okay, left side 37 and fine, it is not calculating the shortest path here. Okay, it starts from the head to, it is moving to the starting position, which means starting node, the head where it is represented. Okay, the head starts at 0. Okay, so from 53 to it is traversing to 50, the 0. In between, what are all the requests are there, that requests are getting satisfied. Okay, for example, if we have some work in one place, so what we plan, what are all the small works available, we need to do in between that place, that small works also are combinedly we are completing. Okay, same thing, start from the 53rd no, coming to the 0, in between what are all the requests are available, that is also getting accepted or transferred by this disk traversal. Okay, so from 53 to 0 it is traversing, then from 0 to immediately it is moving to 199. Okay, from 0 to 199. So to reach 199, in between what are the requests are there, that is also get traversed. Okay, this is the way the scan is working. Okay, so starts from 53. So in between we have 37, 14. I need to reach 0. So from 0 to I need to reach immediately 199. So in between I have this 65, 67, then 98, 122, 124, 193, and 199. No need to move to the dead end. Okay, so what is the final request? In that you can stop. That is scan algorithm. Only it is reaching to the starting node. Starting node to the final request. You please remember this thing. Okay. 0 to starting. After that, starting to not ending. So if it is ending means you need to reach till 199. Okay. The scan is not moving to till 199. Your final request is at 183. So from this it is stopped. Okay, here also you are now again calculating the difference between each request and adding everything. You will get one answer. Okay, like for this scan scheduling, you will get 208. So this 208 is the number of cylinders traversed. Okay, so this is scan scheduling algorithm. So what is first FCFS? So starts from the head. No need to worry about the shortest or larger distance, immediately traverse from one to one, that is FCFS. Then SSTF, start from the head node, check which one is shortest distance. Okay, check the left and right request, which one is shortest, it is traversing to that position. For each request it is checking the shortest distance and traversing. Then scan means it is completely coming to the request to the starting node. So when it is coming from requested edge to starting node, in between points it is traversing. That is called as a scan scheduling algorithm. Okay, the next is C-scan. Another expansion for the C-scan is circular scan. Okay, so here the concept is the head moves from one end of the disk to another end, servicing the request as it goes. Okay, so in the previous one, scan scheduling algorithm start from the request to the start node, not to the end node. Only it is moving to the end of the request. But in C scan, head moves from request to one end to another end. That's why this is called a C scan scheduling algorithm. Okay, in the C scan scheduling algorithm, it is immediately moving from the requested head. Okay, requested head. This 53 to the end. End is 199. So as it goes from the 53rd to 199, in between points it is traversing. Okay, 53 to 65, then 67, 98, 122, 124. After that, 193 till 199. Okay, then from 199 to it is immediately coming to zero without traversing the in-between points, without visiting the in-between points. It is starting from the first request to end. From the end to it is immediately coming to the starting point, which means zero. After that, what are all the missing discs? That discs it is traversing 14 and 37. Okay, this is called a C scan. Okay, so here also same calculation you do. The difference between 53 minus 65 plus 65 minus 67, like that it goes on, you will get some value that is called as number of cylinder it traversed. Okay, and the last concept is C look. So the C look is a version of the scan C look and C scan. Okay, but the concept here is it won't move to the starting as well as ending. Okay, it only moves to the end of the request to starting of the request. Okay, so see here, request start from 53. So when I was reached to move to right side, the end request is 183. Okay, 183 is my maximum request. So to reach 193, the remaining points, when I am goes on, I am visiting. Okay, so 53 to 65, 67, 98, 122, 124, then 183. Okay, I am not moving to 199. Okay, only a needed points I am visiting. Okay, then 183 to it is immediately coming to the starting, not starting node, the first request. Okay, first request we have is 14. Okay, so I'm coming to 14. After visiting 14, I'm visiting the remaining pending sectors, which is 37. So here also you are calculating the same. You will get a one value that is called as number of cylinder it traversed. Okay, so these are the algorithms used in disk scheduling. Okay, FCFS, SSTF, SCAN, C-SCAN, and CLOOK. Okay, so in short, FCFS, you are traversing to the based on first come first service concept. SSTF, shortest distances you are calculating and traversing. SCAN, here you are traversing from first request to starting, then immediately moving to the last request, not the end. Okay, in between, what are all the points we have? That points we are visiting. Okay, then in C scan, starting from the first request to moving to the dead end. Okay, 199 is the dead end. So 199 to I'm again moving to the starting, which means zero, initial. So after that, I'm traversing the remaining points. Okay, in C look from the first request to not moving to first as well as dead end. Only the points I'm traversing to the last request. Last request is 193. So from that, I'm moving to the first request to 40. 14 to the remaining pending. In each request, each algorithm, I'm calculating the difference, that seed time or traversing time from one disk to another. It is calculated which one is having the lowest cylinder rotation. That algorithm is called as the best algorithm. Okay. Thank you.